and welcome to Purple Mountain Maths. Today we're doing the 2025 HSC paper for Maths Standard 2. This is part 2, questions 16 to 19, covering 12 marks. Question 16. Paint is sold in two sizes at a local shop, 4-litre cans at $90 per can and 10-litre cans at $205 per can. Mina needs to purchase 80 litres of paint. Calculate the amount of money Mina will save by purchasing only 10-litre cans of paint rather than only 4-litre cans of paint. Pause here to try yourself. So if using 4-litre cans, she needs to buy 80 on 4, which I can do in my head, is 20 cans. And the cost is 20 times $90 each. I can do that in my head, but you might like to use a calculator. It's $1,800. Let's compare that to the other case. If using 10-litre cans, she needs to buy 80 on 10, which is 8 cans. Cost is 8 times $205. 8 times 205 is $1,640. And I want to do the saving. I want to compare those amounts. So the saving is the difference between those numbers. The saving is $160. Question 17. The scatter plot shows a bivariate data set where x is the independent variable and y is the dependent variable. The points 0, 14 and 5, 4 lie on the line of best fit. Plot the points 0, 14 and 5, 4 on the graph and hence find the equation of the line of best fit. Pause here to try yourself. Okay, so let's plot those points. 0, 14 is here. So when x is 0 and y is 14, and 5, 4 is over here. So when x is 5 and y is 4. Let's connect those using your ruler. Okay, so we're connecting that. We've got this line. All right, so let's now work out the equation of that line. I'm going to use m equals rise over run. I know that this is the point 5, 4. I know that this is the point 0, 14. I notice that that line is falling, so I'm going to expect to have a negative slope. 4 minus 14 over 5 minus 0 equals minus 10 on 5 equals minus 2. Now I also notice that the y-intercept is 14. So using y equals mx plus c, where c is the intercept, I can see that the equation of the line is y equals minus 2x plus 14. And that's my answer. Question 18. A table of future value interest factors for an annuity of $1 is shown. The prize in a lottery is an annuity of $5,000 a year for 10 years, invested at 4.5% per annum, compounding annually. What will be the value of the prize at the end of 10 years? Pause here to try yourself. Okay, so first of all, I notice how often is the compounding happening. I'm looking for that adverb. The verb ending in ly, I can see that it's annually. That's good. It means I don't need to change my n for number of periods, and I don't need to adjust my interest rate because I was already given it annually. So I can see that I'm using the 4.5% column, and I'm also using the n equals 10 row. First of all, I'm just going to identify that table value. So the table value that I'm going to need to use is 12.288. Now, with these tables, future value equals table value multiplied by the contribution. So the contribution is $5,000. and the table value I just worked out was 12.288. Put those numbers into your calculator. 12.288 multiplied by 5,000. I get 61,440 in dollars. And that's my answer. Question 19. The activities and corresponding durations in days for a project are shown in the network diagram as shown. Part A. Complete the table showing the immediate prerequisites for each activity. Indicate with an X any activities without any immediate prerequisites. Pause here to try yourself. Right, so I'm looking at this network and I can see that activity B is at the start. It doesn't have any immediate prerequisites. So I'm going to put in an X as they directed us. Okay, I'm looking at E and its immediate prerequisites are C and D. And when I look at F, I can see that its immediate prerequisite is E. Part B says find the critical path for this project and state the minimum duration for this project. All right, so I'm going to zoom in on my network here. I need to find the earliest start time for each activity as well as the latest start time. So I'm going to put in boxes at each of the vertices. I'm going to use the box on the left for earliest start time, the box on the right for latest start time. And I'm going to start with the left-hand box. So let's first of all just note that A and B start straight away. Their earliest start time is 0. As I move forward, this earliest start time is 3. This earliest start time is 4. Now I need to pause and take care because after doing C, the earliest I could move on would be 6 here. But for this one, 4 plus 5 is 9, and I have to choose the higher of those two values. I can't move forward into E until both C and D are done, so I choose the higher of those two values. I put in the 9. 9 plus 5 is 14. Okay, so 14 plus 7 gets me to 21 up here. 14 plus 3, I could be here as soon as 17 along this path, but up here 21 plus 5 is 26, and I must choose the larger of those two values so I can get to 26. Now let me work backwards. That number goes straight there, 26, 26. Now I'm working backwards and subtracting. I'll do this in a different colour. 21 less 5 is 21. 21 less 7 is 14 coming back from that direction, but 26 less 3 is 21. Now, when we're doing backward scanning, I need to choose the lower of the two numbers, so that makes this one 14. 14 less 5 is 9. 9 less 3 is 6. 9 less 5 is 4. And this one is 3, but this way is 0. I choose the lower of the two numbers, so I'm at 0. Now I can notice the critical path, and the critical path is revealed to me because their earlier start time and later start time are the same, which is like here and here and here and here and here and here, so I can interpret my critical path must have been this path. So my answer to part B, critical path, is B, D, E, F, H, and the minimum duration is 26 days. Part C says the duration of activity A is increased by 2. Does this affect the critical path for the project? Give a reason for your answer. Pause here to try yourself. So, supposing that was a 5, what impact would that have? The answer is no, it does not change the critical path. And the reason is activity C had a float time of 3. So increasing A by 2 days does not change the critical path.